The Particle Photon is a prototyping platform for IoT devices, but is very similar to the Arduino range of development boards. In this how-to, we will learn how to connect circuits to the Particle Photon and about some of the pins on the Particle Photon board. For this project, you will need the following: a Particle Photon board, a tactile switch, a 10K resistor, a 1K resistor, an LED, and a micro USB B cable. The Particle Photon is a single-board microcontroller that is powered by an ARM Cortex M3 clocked at 120 MHz. Capable of being programmed over the air, the Photon is easily configurable and a very hobby-friendly device. Like the Arduino, the Photon has headers that are used to connect to external circuits, and these pins include power, digital signals, and analog signals. The function of each pin is directly printed onto the PCB, which makes identification of pins very easy, but some other functions such as PWM are not obvious. From a glance, it can be seen that the Photon has the following pins: 1 VIN, which is used to power the Photon with an external 5-volt source, 2 GND, which is the common ground point, a 1 TX, which is the serial port transmit out pin, 1 RX, which is the serial port receive in pin, 1 WKP, which is a digital pin for waking up the Photon module, 1 3V3, which is a 3.3V output and can be used for powering external circuits, 1 VBAT, which is used with a coin cell, which can either be 1.6 volts to 3.6 volts, and is used for the internal RTC, and you won't use this in most circuits, and 1 RST. This is the reset pin. But the most common pins that you will be using are the A pins, which are A0 to A5 and are analog inputs and can read voltages, 8 D pins, which are digital pins and can be configured as either inputs or outputs, and 1 DAC, which is the digital to analog output pin. When using the Photon in a circuit, there are a number of ways you can power your project. The first and easiest is to use a micro USB B cable and either connect the cable to a computer USB connector or a mains charge. Connecting to a computer or laptop has the added advantage that the Photon is recognized as a virtual serial port that allows you to communicate with the Photon, whether it be debug information or user input from a terminal. Another method for powering the Photon is to use the VIN input, which takes an external 5-volt source and then internally regulates it to 3.3 for the Photon. However, this method is not usable in a number of projects that use batteries such as 9 volts and 12 volt types and will therefore require an additional regulation stage. For most projects, it's best to use a micro USB B cable. Unlike the Arduino Uno, the Particle Photon is a 3.3 volt device, which means that it cannot be used in 5 volt circuitry. While 3.3 volt inputs can drive 5 volt pins, 5 volt signals cannot be connected to the Photon inputs, and doing so may permanently damage the Photon. Unless bidirectional communication is needed, a simple resistor divider can be used to convert a 5 volt signal to a 3.3 volt for the Photon. This way, a 5 volt device can communicate with the Photon without the need for any other complex level shifter ICs. One feature about the Photon IDE that is helpful is the use of names to refer to pins such as D0 and A3. Instead of having to find the pin number, you can put in pin names. Remember, a pin number is different from a pin name. Reading from digital pins is done using the digital read function, which takes a single parameter, the pin being read. The function will either return 1 or 0 depending on the logic state of the pin, where 1 refers to a logical high, a signal of 3.3 volts, and 0 referring to a logical low, which is 0 volts. Writing to a digital pin is another trivial task, which is done using the function digital write, which takes 2 parameters, the pin that is to be written to and its value. The value is either high or low, and these two refer to either logical high of 3.3 volts or logical low of 0 volts respectively. In our example, we have a particle photon that flashes an LED multiple times when it detects the push of an external tactile switch. A pull-down resistor, the 10K, is used so that when the switch is left unpressed, the pin DO is connected to the 0 volt through the resistor, which reads 0 volts. When the switch is pressed, a direct path between a 3.3 volt and D0 is made, and so it reads 3.3 volts and therefore a logical high.